Okay guys, and so today I'm going to show you how to make solutions, and we'll be doing a lab on this in the near future. And so you've learned about the molarity equation. Molarity equals moles per liter. And so how do we actually apply that and actually make some chemicals in the real world in a laboratory environment? And so here's your question. How do you make 500 milliliters of 0.25 molar salt solution? And so what we have to find out is we have to find out how many grams of salt we're going to use to make this solution. And so we're going to rearrange our equation here. So moles would be equal to molarity times liters. The molarity was given to us as 0.25 molar. So 0.25 molar. The liters is given to us as 500 milliliters. So convert that to liters. So 0.5 liters. And then that is going to equal, so 0.25 times 0.5 is equal to 0.125 moles of salt. Alright, so we'll take that moles of salt, that 0.125 moles of salt, and we're going to convert that into grams of salt, so 58.443 grams, 1 mole of salt. So that's molar mass. So that gives you 7.31 grams. 7.31 grams of salt. So what does that mean? Well, that means that in our 500 milliliter solution, we're going to have 7.31 grams of salt. So we just need to actually make it now. Make that solution, and we'll have our solution that we need. So let's do that. So we're going to have 7.31 So we're going to have 7.31 grams of salt, and we're making a 500 milliliter solution. And so what we're going to do is we're going to take a volumetric flask, if I can draw a volumetric flask. If you remember, the volumetric flask has a long stem and then a round flask at the bottom. And somewhere on this stem is a mark. And that's the only mark on this flask. And that mark, we're going to take a 500 milliliter flask. There are other flasks as well, but this one's going to be 500 milliliters because we're making 500 milliliters of solution. And we're going to add some water to that. So normally what you do, you'd add some water to it. Not 500 milliliters, but just some. And then what you're going to do is you're going to take your 7.31 grams of salt and you're going to put it in there. And you can swirl it up and shake it around to get that salt to dissolve. And then you're going to add more water, however much more water you need, so that the level of the water increases until it gets to the mark that is 500 milliliters. And we want to put the bottom of the meniscus at that mark. I'm a little off there. And so if we put the bottom of the meniscus there, we now have a 500 milliliter solution. Remember, the 500 milliliters is the whole solution. Water plus salt. What you don't do is you don't put 500 milliliters of water in here and then add the salt, because the salt will take up room and it's going to make the water level rise above 500 milliliters. And so a 500 milliliter solution, and inside that 500 milliliters of solution we have 7.31 grams of salt. And so that would be the solution that we want to have. That's how you make these solutions. It's not a very complicated process. And you're going to do some of this in a laboratory environment. Now, I also want to talk about making dilutions. And so a dilution is something that is less concentrated. And so we're going to, in making a dilution, we're going to take something that is concentrated and we're going to dilute it to make it less concentrated. And so there's a formula for making dilutions that we use. It's a real simple little formula. It's actually on your reference materials, and it's in the form of V1 M1 equals V2 M2. And in this formula, the V's stand for volume, and the M's stand for molarity. And so one thing to note in this formula, our volume is actually volume. It's not liters like in the molarity equation. It's moles per liters. You must use liters. This is not liters. This is just volume. So you could use milliliters, liters, gallons, whatever, ounces, whatever you happen to have. So you don't have to convert to liters with this equation. And so what this does is this equation lets you have two samples, so like concentrated, that would be this. This is your concentrated solution, which we call the stock solution. So concentrated is stock. And then this over here, this is your diluted solution or your dilution. So what's the volume of our concentrated, the molarity, and the volume and molarity of our dilution. And so let's do a problem for making dilutions. All right, so here's our question. How much of an 8.5 molar stock solution is needed to make 500 milliliters of 0.75 molar dilution? And so our equation is V1M1 equals V2M2, remembering that this is your stock solution over here and this is your dilution over here. And so the question is how much of the stock solution? So our V1 is our unknown. So V1 is our unknown. What is the molarity of our stock solution? Well, the problem says that it is an 8.5 molar stock solution. So we'll put 8.5 molar here. And then we're talking about our dilution. So in our dilution, what's the volume of our dilution? It's 500 milliliters. And we can use milliliters here. We don't have to convert to liters because it's just a V, and milliliters is a V. And then what's the molarity of our dilution? We want our dilution to be 0.750 molar. So there's your setup. And then you just solve this algebraically. We're going to divide both sides by 8.5 molar. Over here they cancel, and V1 is equal to, over here the molar cancels molar, the unit molar cancels molar. Do your math here, 500 times 0.75 divided by 8.5. You do that math and you get 44.1 milliliters. All right, so what does that mean? Well, here's what that means. Again, so actually making a solution. You're going to once again take a 500 milliliter flask, volumetric flask. So we've got that mark on here somewhere that says 500 milliliters. If we were making 1,000 milliliters or 250 milliliters or 50 milliliters, we would use that size flask. In this case, we're using a 500 milliliter flask. And into this flask, we're going to place 44.1 milliliters of our stock solution. So you'll just go to your stock solution and use a graduated cylinder or a pipette or some type of measuring device, and you're going to measure out 44.1 milliliters of that stock solution. You'll put it in there, and then what you're going to do is you're just going to take some water and you're going to add the water to that flask until the level reaches 500 milliliters. And then when you add the water, you dilute the solution, and so it's diluting to 0.750 molar when you reach the 500 milliliter mark. And so that's how you make your dilution. Take the amount of your stock solution, put it in there, dilute it with water until it reaches a total volume of 500 milliliters. We do that because we don't want to dilute our stock solution. We want to take part of our stock solution and dilute it. We don't want to dilute our entire stock solution to this new dilution, because then if we want to get something more concentrated, well, we're too dilute to begin with. So that is how you make solutions, and that is how you make dilutions. So you have a new formula today, so make sure you know it. We're going to work with it in class. So V1M1 equals V2M2. It is on your reference material sheet under the solutions section, and so that is one that we're going to be using. See y'all tomorrow.